Welcome, my friends! In this video, we will discuss similar triangles. Similar triangles are two triangles that have the same interior angles. The mathematical term for this is congruence. The two triangles must have congruent angles in order to be similar. In practice, this means that two triangles are similar if one triangle is a scaled version of the first triangle. Two similar triangles have the same shape or form, but not necessarily the same size. Scaling up a triangle by proportionally increasing the length of each side creates a similar triangle. For example, these two triangles are similar because their interior angles are the same. The first triangle is smaller than the second, but that doesn't matter in terms of similarity. The interior angles are the same, so these two triangles are similar. Note that the little square on the bottom left of each triangle indicates a right angle of 90 degrees. Also note that since the interior angles of a triangle always add up to 180 degrees, you really only need to know that two of the interior angles are equal to know that two triangles are similar. For example, if I only knew these two angles, the right angle of 90 degrees and this angle of 37 degrees, I could solve for the third angle by taking 180 and subtracting 90 and 37 to get 53. If you know two angles, you can always solve for the third. So you really only need to know that two angles are equal to know that two triangles are similar, because if you know two angles, the third can always be calculated, and you would get the same answer for both triangles. Let's put some numbers on the side lengths of the smaller triangle. Let's say the base is 3, the height is 4, and the hypotenuse is 5. If I told you that these two triangles were similar, and that the second triangle is twice as large as the first, you can find all the side lengths of the larger triangle by simply multiplying each side of the smaller triangle by 2. 3 times 2 is 6, 4 times 2 is 8, and 5 times 2 is 10. We call 2 the scale factor. You could also go backwards, so if you already know that two triangles are similar, but you aren't sure how much bigger or smaller one is compared to the other, just find the ratio of two corresponding sides to solve for the scale factor. For example, if we took 6 and we divided by the corresponding side in the smaller triangle of 3, we would get 2, which tells us that the second triangle is twice as large as the first, something we of course already knew in this example, but might not be known in other circumstances. Generalizing this idea, for similar triangles, corresponding sides are proportional. To find the scale factor between two similar triangles, divide two corresponding sides. Consider this example. There are two triangles in this picture, and it might be useful to write them out side by side. This is what we have. The height of the smaller triangle is 6, and the height of the larger triangle is 6 plus 3, which is equal to 9. The base of the smaller triangle is 3, and the base of the larger triangle is x, the value that we would like to solve for. Are these two triangles similar? Remember that two triangles are similar if they have the same interior angles. Remember that we only have to show that two angles are congruent, because if two angles are equal, the third will be as well. These two triangles both share a right angle, so that's one out of the two that we need to show. They also both share this angle up here. Since we have shown that two angles are congruent, we know that the third angle will also be congruent, and we therefore have similar triangles. What is the scale factor between the two triangles? Well, the scale factor can be found by dividing two corresponding known sides. If you take 9 and divide by 6, you will get the scale factor, which is 1.5. That means that the second triangle is 1.5 times larger than the first. That also means that the base of the larger triangle must be 1.5 times larger than the base of the first triangle. 3 times 1.5 gives us 4.5. So the base of the second triangle must be 4.5. What about these triangles? Let's see if we can solve for x. I can already tell that these two triangles are similar, as two angles that cross each other in this sort of x shape will always be equal. We also have right angles in both triangles, meaning two of the angles are equal. If two angles are equal, the third will also be equal, meaning that we have similar triangles. There are two ways you can approach what to do next. You could try to write the triangles both right side up, so you can more easily determine which sides correspond to each other. I'm just going to rewrite the top triangle next to the bottom triangle so that they are both oriented in the same way. The base of the rewritten triangle is 3.5 and the hypotenuse is x. Alternatively, if you don't like rewriting the triangle, you can label the sides and figure out which sides correspond to each other. AC corresponds to AE, AB corresponds to AD, and BC corresponds to DE. I can sometimes get a little bit confused trying to match things up without rewriting the triangle, so use whatever method works for you. Okay, back to my redrawn triangle. Let's find the scale factor. 3.5 divided by 3 is approximately 1.167, meaning that the second triangle is 1.167 times larger than the first. That means to find the missing side, I can multiply 6 by 1.167, which will give you 7. The missing side length is 7 units. Make sure to use all the decimals the calculator gives you in the scale factor. Otherwise, your final answer might be off a bit. Let's try a story problem. A pole that is 2.5 meters tall casts a shadow that is 1.69 meters long. At the same time, a nearby building casts a shadow that is 50.5 meters long. How tall is the building? Round your answer to the nearest meter. Let's try to draw the picture that represents this example. We have a pole over here that is 2.5 meters tall. The shadow cast by this pole at a particular point in the day is 1.69 meters. Shadows are cast onto the ground, so the 1.69 meters must be a base measurement. We can connect these lines with a hypotenuse to form a right triangle. The sun would hit the top of the pole right here, and based on the angle that the sun hits the pole at, we would create this shadow, which they are telling us is 1.69 meters long. Let's draw the building. They tell us that the shadow cast by the building is 50.5 meters long, so that is a base measurement onto the ground. We would like to find the height, which is our unknown value that we can label as x. We can also connect these lines with a hypotenuse to form a right triangle. Do we have similar triangles here? Well, I already stated that each triangle is a right triangle. How did I know this? Well, I'm assuming that the building and the pole are constructed straight up into the air. We don't have a bent pole or a leaning building of Pisa or something like that. Also, the shadows are cast directly onto the ground. I guess you could argue that there is a slight curvature due to the spherical shape of the Earth, but the effect is extremely small. The shadows are, for all practical purposes, a straight line perpendicular to the pole or building. If you know that you have two lines that are perpendicular to each other, they are going to form a right angle, which is how I know that we have right angles for both of our triangles. We need to show that one of the other angles is equal to know that we have similar triangles. The problem states that the shadows are formed at the exact same time. That means that the sun is in the exact same position when the light hits either the pole or the building, and therefore will hit the top at the same angle. Again, there is a negligible difference due to the building being slightly closer to the sun since it's taller, but a few meters isn't going to make much of a difference for the sun, which is 91 million miles away. Therefore, we have two similar triangles. The second one, related to the building, is just a scaled-up version of the first one. To find the scale factor, divide corresponding sides. 50.5 divided by 1.69 gives you about 29.88, meaning that the building is 29.88 times larger than the pole. Multiply the height of the pole by 29.88, and you will have the height of the building. 2.5 times 29.88 is equal to 74.7. Make sure to use the unrounded version of the scale factor when multiplying by the height of the pole. Since the question asked us to round our answer to the nearest meter, we can state that the building is about 75 meters tall. Alright my friends, that wraps up my video related to similar right triangles.